All right, how's everybody doing today? This is Mr. Muscarella coming at you, and today we're taking a look at how to find the inverse of a function. So hold on, there's going to be 4 simple steps for this process. Now the first step is going to be involving the domain of the original function f, because if f is not 1 to 1, then we've got to redefine that domain so that f is going to be 1 to 1. And just kind of as a quick review of that, usually it involves some sort of quadratic function. So if you had a quadratic function, that function is not going to be 1 to 1 because it's going to fail. Remember the horizontal line test? So it's going to fail the horizontal line test. So we're going to have to do something to restrict that domain so that the function would be 1 to 1. And that's what step number 1 is getting at. Step numbers 2, 3, and 4, those will be the ones that you're pretty familiar with. The first of those is you're going to switch the variables x and y. Then the third step is going to be solve for y. Make sure that you write it in the explicit form. Now the fourth step is going to vary from textbook to textbook and teacher to teacher. Sometimes they'll have you verify the result, and other times you won't have to do that. So that's just going to be a teacher and or a textbook preference. But you should already know at this point how to do the composition of 2 functions. So we're going to take a look at 2 examples here, and let's go ahead and get right into these. So we're going to do 2 things here. We're going to find the inverse of the function, and we have to state the domain and range of both the function and its inverse. So if we take a look at the original function, now here it's pretty straightforward to see for the domain of this, because right here, if you look in the denominator, we don't want that to be 0. So since that piece can't be 0, that means x can't be equal to -7. So that's going to give me my domain restriction. So my domain, x can't be 7, and then if I write it using interval notation, that means I'm going to go from -infinity to -7, again with soft brackets, along with -7 to infinity. Now for the range, what I want you to do for the range is pay attention to the 4x in the numerator and the x in the denominator. At this point in your math careers, all I want you to be able to do is take a look at those 2 values. You're looking at the highest degree in the numerator and in the denominator, which in this case is 4x over x. Now what you're going to do to find the range for the original function is you're going to take the ratio of those 2 if the degrees are the same. And in this case, the degrees of 4x and x, both of those have an exponent or a degree of just 1. So we're going to go ahead and write the range, and we're going to say the y value can't be 4 because 4x over x, so just kind of real quickly here, if you were to take those 2 again, so 4x divided by x, that's just going to give you 4. So my range is going to be y cannot be 4, or if I write that using interval notation, we'll go from -infinity to 4, and then 4 to infinity. So you'll practice that a little bit more, and that's going to become an important concept later on when you take a calculus course, but for right now, that's all I want you to be able to identify. So we've got the domain and range of our function sorted out. Now the next piece we're going to do is we're going to go ahead along with the rest of the steps. Now step 2 said just switch the variables x and y. Well, right now we just have f of x, so that's just a real fancy way of saying y. So we're going to have y equals 4x minus 1 over x plus 7. And then comes the switch. So the next thing we're going to do is we're going to switch every x is going to change into a y, and every y is going to change into an x. So that will give us this step. Now what we're going to do next is we're going to take the denominator and we're going to multiply that to the left-hand side. We're going to multiply both sides by y plus 7. When you do that, you'll end up with the quantity xy plus 7x on the left equals 4y minus 1. Now the next piece, what we're going to do is we're going to get all of the y terms on the left and all of the x terms on the right. I'm going to do this all in one step here. We're going to move pretty quickly here. So on the left-hand side, we're going to have xy minus 4y, and on the right-hand side, we're going to have negative 7x minus 1. Now we've got a couple more steps to go. And here's what we're going to do on the left-hand side. We're going to factor out a y. And that's going to give us y times the quantity x minus 4 equal to negative 7x minus 1. Now when I solve that for y, I'm just going to simply have y equals negative 7x minus 1 in the numerator and then x minus 4 in the denominator. But I'm not done. This is a common mistake a lot of people make. They'll just leave it at that and say, okay, y equals blah, blah, blah is the inverse. Don't do that because that's wrong. You have to do one more piece, and that is write it using correct notation. And that notation is going to be f inverse of x equals negative 7x minus 1 over the quantity x minus 4. So make sure that you take it to that last step. Now we've gotten this far, so we found the inverse. Now the last thing we have to do is find the domain and range of our inverse function. So I'm just going to kind of rewrite that up here. Now my original function was f of x equals 4x minus 1 over quantity x plus 7. Now notice the domain and the range on the original function. Compare that to the domain and range of your inverse function. Notice what happens. If you look at the denominator of your inverse, you can tell that x can't be 4. Because 4 minus 4 gives you 0, and 0 in the denominator, we all freak out over that, so we have a domain restriction there. So x can't be 4, so we write our restriction using interval notation. We do the same thing for the y's. And again, with the y's, what you're going to do to take a look at the range restriction is you're going to take a look at the ratio of these two terms right here, the negative 7x and then the x. Since both of those have the same degree, we can simply just do a quick reduction here. Negative 7x over x, that's just going to reduce down to negative 7, or simplify to negative 7. So our range restriction, our range is going to be all real numbers except for negative 7. And then again, when we write that using interval notation, you'll have from negative infinity to negative 7, along with negative 7 to infinity. Now let's go ahead and try another example. We've got one more example to kind of go through. Now here, in this example, we've got g of x equals x squared plus 3. So you should recognize at this point that that's going to be a parabola with a vertex at the point 0, 3. So the domain of g is going to be x is greater than 0, because what we're going to do with this is we're just going to restrict our domain, because we've got to do that. This is one where the original function, oh my gosh, look, it fails the horizontal line test. So I have to make sure, in order for this to be able to work with the inverse, I've got to just restrict that. So what I'm going to do is only deal with this part right here. I'm just going to deal with the right hand side. So I'm going to go from 0 on the x-axis, and it can be any number more than 0, because I'm going to go to the right forever and ever, so that's going to be from 0 to infinity. Now my range, so my range on this is going to go from the 3, because that's my y coordinate. So I'm going to go from 3 up forever and ever and ever, or using interval notation, I'd have 3 to infinity. But on the 3, make sure you have a hard bracket, because that is included there. Now the rest of it is going to be straightforward. I think you guys will be okay with that as you move forward to take a look at the finding the inverse of the original function. We're going to write g of x in terms of y. The next thing we're going to do is we're going to switch x and y, so we'll have x equals y squared plus 3. And then we're going to move the 3 over, so we're going to have x minus 3 equals y squared. Now normally when you take the square root of both sides, you're going to take plus or minus the square root. But look back up to our domain restriction of g. We wanted all of our x's to be greater than or equal to 0. So we wanted only the positive, what we're going to do is only deal with the positive square root of x minus 3, instead of both the positive and the negative square root of x minus 3. But then again, don't forget to write it using explicit notation. So we're going to have g inverse of x equals the square root of x minus 3. Now again, see if you can recognize that pattern from before. I'm going to take my domain and range of my original function, and they're going to get switched for my inverse function. So my x's have to be greater than or equal to 3 for my inverse, which, because we have a square root function, we can't have a negative square root. So that's why x minus 3 has to be greater than or equal to 0. which gets you a hard bracket when you write it in interval notation. Same thing for the range. The range for G inverse is going to be all y's greater than 0. Because if you were to graph this function, if you wanted to take a look at this from a graphical perspective, our inverse function would look like this. We would start at the coordinate 3, 0, and we would just go like this. All right, so that is how you find the inverse of a function, and I've shown you guys how to state the domain and range of a function, both with the original function and its inverse. All right, thank you for watching this one, and I will catch up with you guys soon in another video. Peace out.